Hi everyone, this is Hans from Tundra Feed and Supply Company. Today we're going to be going over the fundamentals of projectiles for a 2D game. We'll specifically be making this for a top-down game, however these systems will also work for side-scrollers. We'll be using composition to create an extensible hit detection system with a deeper look into CollisionShape2D and Area2D nodes. We'll discuss collision layers and masks, and also utilizing signals. We'll also introduce how to set up our project to utilize pixel-style graphics. We'll also discuss both the GDScript and C# implementations in greater detail as they diverge when setting up signals. In this video, we'll be making use of the Kenney Tiny Battle asset pack. These assets are completely free, so if you'd like to download them, you can go to kenney.nl/assets/tiny-battle to follow along. However, they are not required to follow along with this video. Okay, so here we are in our basic 2D project. At this point, we have a world node, which is just a node 2D, and our player, which is just as created and programmed as our previous fundamentals of top-down character movement video. I've gone ahead and added a tile map utilizing the assets from the Kenney Tiny Battle pack. However, that is not required. And I won't be covering tile maps today, as they are a significant topic in their own right. This is not required for the video. This is just something that makes our character moving around look a little bit nicer in this world. Okay, so our first step, we're going to want to go over to our player scene, which I've gone ahead and opened already, and we're going to want to change our sprite with one of the new Kenney sprites. So let's go ahead and remove the Godot logo, and then where it says empty, let's go ahead and hit load. Now I have structured our project right now with an assets folder, which is where the Kenney assets are, our entities folder, which is going to hold our player and things like our projectile and the target that we're aiming to hit as we develop, and then our levels. Levels are areas where our player is going to be moving around. So that's going to be our world, for instance. Nothing was displayed here at this time because the only thing saved in levels is our world scene, and since this is a sprite dialog that's been opened, it's not displayed as something that we can click upon. So let's go ahead and go into the assets folder, and then for me, there's the Kenney Tiny Battle. We're going to go into our tiles. I'm going to go ahead and scroll down to these blue ones down here, and I'm going to go ahead and select tile 0134 because it's a tank. So let's go ahead and open that up, and we'll zoom in since these are 16-bit assets. Let's take our CollisionShape2D and shrink it down to fit our player. Now something you'll notice, and I wasn't very precise with this, we can go ahead and expand that a bit. So you'll notice for a 16-bit asset pack, even though the images themselves look clear, this looks very fuzzy in Godot. And the reason being is because of how we have the renderer set right now. So let's go ahead and click Project and then Project Settings. So from here, we're going to want to scroll all the way down to our rendering and click on Textures. Then, under Canvas Textures, where it says Default Texture Filter, we're going to want to switch from Linear to Nearest. So again, that's General, under Rendering, under Textures, and then under Canvas Textures, change Default Texture Filter from Linear to Nearest. If Advanced Settings is off, this is a little bit easier to find. However, for later on in the project, we will need our Advanced Settings turned on. That is still here, it just might be a little bit harder to find in this dialog. And then we can go ahead and click X on this dialog, and you'll notice that our tank is crystal clear as the image was originally. So let's go ahead and save this. And you can leave the sprite above the collision shape or below the collision shape. It does not matter. Okay, so back in our world, if we were to go ahead and run this again, we'll notice that our player is very small. So in order to address this, we're going to go ahead and go to our project settings again, and this time we're going to go to Window under Display. We're going to change the viewport width and the viewport height. So for width, we're going to set this to 640, And for height, we're going to set this to 360. These are the standard values for a 1920 by 1080 display for 16-bit assets. So now we're going to go ahead and close this dialog, and we're going to play our game again. Our game is now set to the 640 by 360 aspect ratio. But of course, now it's very small. We can expand it. However, you'll notice, rather than making our game larger, we've just increased our field of view. You can now see where the tile map ends. So there's another thing for us to fix. So let's go to Project Settings again, and this time, again under Display, we're going to scroll down to Stretch, and then we're going to look at Mode. Right now, this is set as Disabled. So what we're going to do is we're going to set this now to Canvas Items, and all these other default settings we're going to keep. So again, we're going to X out of this dialog now, and we're going to run our project again, and it'll start in this small box, but then we're going to go ahead and expand it, and now we can see our game much nicer. So one other thing to do, if we don't want to have to expand the screen every time, so what we can do is we can again go to our project settings, and again under Display, under Window, we can see Window Width Override and Window Height Override. So what we're going to do is set Window Width Override to 1920, and then Height Override to 1080. So we can go ahead and close this dialog again, and if we run our project again, it'll now open at that size naturally. Okay, another quick thing to note is that our tank is moving pretty quick, so I'm going to go ahead and slow that down. I'm going to go over to our player script, and I'm going to change the speed from 20,000 down to, say, 5. And I'll save that, and we'll run this again. And we can see that's a much slower value that feels much better for what I am thinking of. Okay, something else that you may have noticed is that if we switch to the player scene to open up the player script, and we hit play, we actually run the game in the player scene, which is not necessarily what we want to do. So something else we can do is we can hit the Run Project button. So let's go back to our world scene, and when we hit Run Project, it's going to tell us that no main scene has ever been defined, and ask us to select one. If we had a larger game here, this might be an instance where you want to set the main menu as the main scene. So for us, since we're in the world scene, we're going to hit Select Current. That will now be the scene that starts up every time we hit the Run Project button. So while we're in the player scene, if we were to click Run Current Scene, the player scene will run. However, if we click Run Project, even though we're in the player scene, it will take us to our world scene. Okay, with all of that set up, let's go ahead and create our projectile. So for that, we're going to go ahead and create a new scene. You can go ahead and hit this plus button up here. Alternatively, on Windows, you can hit Control-N, and that'll automatically open a new empty scene. Now for us, for our current root node, we're going to click Other Node. And the reason we want to do this is because we want to select an Area2D. So our projectile, we want this to be as simple as possible. Since potentially there are going to be many different projectiles in the game at once, we want this to remain uncomplicated. Every single line of code, every single hitbox or collision check is memory overhead for your game. It's something that your game has to be processing. So ideally, we want to keep our game as simple as possible programmatically. That way our game is efficient and can run on as many machines as possible with a consistent high frame rate. So we don't need this to be a character body 2D or a static body 2D. An Area2D will suffice. Now, we get this little icon here, and that's saying that we don't have a collision shape. So for our Area2D, we're going to go ahead and add a child node, and this is going to be our CollisionShape2D. From here, once again, this is giving us another icon saying that we don't have a shape specified. So before we do that, we're going to go ahead and add a sprite here so that we know what the shape of our projectile is going to look like. So let's add a child node and grab a sprite2D. I'm going to move the sprite2D above the CollisionShape2D, although functionally that does not affect anything in our game. So let's go ahead and move over and zoom in, even though we don't have a sprite selected yet. So with our sprite2D node selected, over in the inspector under texture, where it says empty, go ahead and click that drop down and hit load. Now, this is completely acceptable to use the icon again. For instance, if you're not using the Kenney Tiny Battle asset pack, you can just use the icon, or you can use the assets for whatever game you're making right now. But all of this is fine to use. This is all just for this example. So I'm going to go into my assets folder and go into the Kenney Tiny Battle folder, and then go to our tiles. And I'm going to scroll all the way to the bottom where there is a projectile, tile 0191, and we're going to click open. Okay, now we'll zoom way in and we can see our projectile here. So now when we click on our CollisionShape2D node and assign a shape in the inspector, we're going to go ahead and grab a new capsule shape 2D. So this should fit our sort of oblong shape of our projectile sprite here perfectly. If you notice, though, it's at the wrong angle. So you can click the rotate mode or hit the button E, and you can go ahead and rotate this. However, that's relatively imprecise, at least for me. So I'm actually going to remain on the cursor, and over in the CollisionShape2D inspector, under transform, I'm going to go to rotation, and I'm going to type 90. There we go. So now we've spun this 90 degrees. And then I'm going to go ahead and shrink our capsule up to fit our projectile. And I'll leave it a little bit larger. Generally, it's a good game design principle to, while keeping things feeling fair, generally skew things towards the player to give them favor. Of course, we could make this pixel perfect, although, again, that can also, depending on how complicated your collision shape is, that can also make things more complicated. Probably not something we need to be concerned about here. But pixel perfect can oftentimes feel unfair to the player. But, of course, do whatever is appropriate in your game. Okay, so here is the layout, at least the node layout of our projectile. So let's go ahead, and I'm going to hit Control-S to save the scene. We're going to go into the Entities folder. We're going to create a new folder called Projectile. And then we're going to save our scene. Right now it wants to be called Area_2D scene, and that's because of the name of the node here. So we'll go ahead and rename the node after we save this scene, but we're going to call this scene Projectile. Okay, and then let's also go ahead and rename this node. Now, one of the reasons why we want to do that is because, despite the scene name, when we instantiate our projectile in other scenes, as we'll do here shortly, as the player is firing projectiles, those nodes will just appear as Area2D, and that can become a bit confusing. Okay, so I've gone ahead and saved that again, and now we have our projectile. Now, something that's important for us to touch upon is clicking on the projectile, which is the Area2D node. In the inspector, under Collision Object 2D, there's a collision tab. If we expand that, we have two things here called layer and mask. So these are simply things that we can assign our collision to. Now, to cover this in a basic manner, what this means is that, for instance, this projectile will collide or hit or interact with things on layer or mask 1. If we then add it to 2, it will interact with things on layer and mask 1 and 2. If we remove the 1, Now it's only going to be interacting with things on 2. To be more specific, the layer here is the layer that this collision object exists in, whereas the mask is the layer that this collision object is scanning for. So for instance, when this thing has a signal, for instance, that has, say, on area entered, it would be scanning for things on, if we click 2 here, it will be scanning for other things it's colliding with on mask 2. So if something were on mask 1, the on area entered for this particular projectile, and I'll set this back to mask 2, right? So if something that is on mask 1 goes over this projectile, the on area entered signal won't fire for this projectile because it is only scanning for things on mask 2. And so that is the primary difference as well between layer and mask. So layer is the layer that it exists on. Mask is the layer that it is scanning for. And this applies for anything that has a collision shape associated to it. So this is the same for Area2D. It's also the same for our player. Now, this distinction is important because we're going to have drastically different logic depending on what objects are entering certain areas. So for instance, for our player, we'll navigate back to the player scene real quick. The player, which is a character body 2D node, has a CollisionShape2D node attached to it. If we look in the inspector, under character body 2D, we have our collisions here. And the collisions for our player, for instance, these are what it's colliding with, for instance, walls in the world, potentially other enemies or other players, or so on and so forth, that we don't want our player to be able to walk through, right? We would not necessarily want to assign our projectiles to this. For instance, if our player was going to have health, we would actually assign another Area2D to this, and then another CollisionShape2D. And on top of this, we would then attach a script specifically for this particular collision shape. And the other nice thing here is that we can then differentiate the collision shape of our hitboxes from, for instance, the things that are keeping us from moving inside of walls, so on and so forth. And this is something we're going to build upon later. Okay, so for our player here, we're going to go ahead and remove this Area2D node for now. For this particular instance, I was using that as an example. So we've gone ahead and left our player scene as it was. So our player is still on layer 1 and mask 1 for its collisions. So now moving back over to our projectile, our projectiles layer and mask, we're going to take mask 2 off because we're not going to have our projectile scanning for what it's potentially hitting. We are just going to let our projectile stay on layer 2. And the reason that we're doing this is because we're going to create a target object, and this could also be an enemy object, and it is going to have a signal scanning for collisions on layer 2. That's going to be our hitbox, where if it touches our projectile, which exists in layer 2, it will then trigger a certain set of steps. In our instance, this will be the object queue freeing. However, we could then, with composition, build that out to include a health component. So another thing that we're going to go ahead and do here is we're going to rename our layer. So right when we hover over this right now, it says layer 2, but we can make this a little bit clearer for ourselves. So go ahead and go to Project, then Project Settings. And we're going to go ahead and scroll all the way down to layer names. And we're going to go to 2D physics. So right here, we can see all 32 layers as they're listed out. What we're interested in is layer 2. We are going to title this Projectiles, because this is going to be the layer that all of our projectiles are going to be on. Okay, we can go ahead and exit out of project settings. And now, if we hover over layer 2, rather than saying layer 2, it now says projectiles. So that can be another thing that makes it a little bit easier to navigate and to continue to build off these aspects as we go forward. Okay, so let's go ahead and get into the functionality here. So make sure that you have selected your projectile node, and we're going to hit attach new script. So this is going to be named Projectile, so this is great, and I'm going to go ahead and program this in C#. However, there is some differentiation here, and so we'll make sure that I cover the GDScript as well at the same time. So other than that, you can follow along in GDScript if you'd like, or you can choose C#. These details are all okay, and we are inheriting from Area2D. So let's go ahead and click Create. I'm going to go ahead and expand this so it's a little bit easier for us to see. So the first thing we're going to want to do is we're going to go ahead and create our speed for our projectile. So this will be a private constant float. We'll call it speed, and we're going to set it to something like 700 for now. And later on, we can change that value to whatever is feeling best for your game, although 700 is something that has felt okay with this so far. So I haven't gone ahead and explained what a lot of these mean. However, I'll touch upon them briefly just in case it's something that you're unfamiliar with. So speed is the name of our variable, and this is the value that we're assigning to it. So we're assigning a float value. Float stands for is a floating point value. What that means is that it can have a decimal. Typically, one of the more basic variable types is an int, which stands for integer, which means that is essentially a rounded value, 1, 2, 3, 4, so on and so forth. Float could be 1.7, 1.73, and so on and so forth. So float is very common for games, and it's very common in C#. What the const stands for is constant, and so that just means that this value cannot be changed later. That's a great way to keep things safe for any variables that are critical to be used throughout your application. We don't want our projectile speed to be changeable by something else, so at this point in time it's constant. Now, if we were building our game to be able to modify the projectiles, and maybe you have something that changes the speed or the speed of the projectile's variable as it flies, then that is something that we would implement this differently. But for us right now, our projectile is going to be fired from our player, move at a constant speed, and when it's going to hit our object, it is going to disappear. And so constant works well for this. And then finally, private, because we do not as well want this value to be changeable outside of our projectile class here. Public, generally speaking, means that this is accessible outside of the class and is something that can be called, read, and changed. And so for us, this is something that it just exists for our projectile. So private is a very easy label to choose for our variable. Okay, so with that out of the way, let's go ahead and remove this ready for now. Now, we are going to add that back in later. However, I want to illustrate a point here real quick, so we're going to go ahead and leave that for now. So by default, we have a process here. However, I'm going to go ahead and remove that comment, and I'm also going to change this to physics process. Oh, if I can type. Okay, now what we're going to want to do in our physics process is move the position of our projectile. So let's go ahead and call the position, and then we're going to say position plus equal to transform.x times, and then in parentheses, speed, and then our speed is going to be multiplied by delta. And since delta is a double, we have to cast it to a float. And also, again, we're multiplying our speed by delta. That way our speed is consistent across variable frame rates. Now, for now, this is what our projectile is going to look like. We've chosen our x here because if we go back to our 2D scene, Up and down is the y-axis, left and right is the x-axis, and we would like our projectile to move in this direction, right across the screen. So that's going to be on our x-axis. So let's go back to our script, and let's go ahead and save this. Another thing that we can do for now is we can hit gd.print, and we can tell this to print the position. So this is how in C# we can print to the console. In GDScript, you should just be able to call print as it is with a lowercase p. However, for C#, we need to call the GD namespace here from Godot and then call print. Okay, let's go ahead and save this scene. And now that we have our projectile set up, we're going to go ahead and set up a way for our player to actually fire this. So let's move over to our player scene. And the first thing that we're going to do is we're going to actually go to our project settings again, and we're going to go to our input map, and we're now going to add our new action for attacking. So let's go ahead and name this attack and click add. From here, let's go ahead and add an event, and then I'm going to click my left mouse button as our attack, and I'm going to click OK. Okay, so now we have our attack input set up. So let's go ahead and close this. So let's create a new method here. It's a private void called attack. Okay, so furthermore, private, similar to the variable declarations, means that we can't call attack from outside of the player class. And void means we're returning nothing at the end of the script. For instance, if we wanted to say return a value like damage, for instance, then we would need to specify this as int or float, depending on what we're returning as damage. But in this instance, we're not returning anything, same as in handle input, so these are voids. As another addition to that, these have overrides because physics process is a function inherited by character body 2D. So when we override, what we're saying is don't use the physics process that character body has already written. Instead, use what we have written for physics process. So that's what all of these labels mean around our functions. Okay, so with our attack method written, let's go ahead and program this out. So first, what we need to do is take in input. So we're going to check if we are attacking. So let's go ahead and write an if statement. And inside the condition, we're going to write input.get action just pressed. And I made a mistake there. It's not get, it is action just pressed. And as what we've done for up above with our input.getVector for movement, we're now going to pass in the name of our action, which, as we have now defined it, is attack. So let's go ahead and open this up and also write gdprint attack. Okay, and go ahead and make sure that you are adding semicolons. I'm going to go back to our projectile script because I believe I forgot to add them. Okay, there we are. Okay, so here we are now, and in our attack script, in our attack method, if attack is clicked, attack will be printed. Now, there's several variations of is action pressed upon input. The reason why we want to check just pressed is because we want to fire off one attack when the player clicks. We are not interested in firing off an attack for every frame that the left mouse button or the attack event is being triggered. Now, that is something that you could implement. However, if you do that, at this point in time, the attack will trigger every single frame of the game. And Alternatively, if we would like to hold that down and have, for instance, a rate of fire, you would need to implement some form of timer to make sure that while the mouse button is being held down, if it is a certain amount of time has passed and another projectile can be fired. We're not interested in doing that for right now. Right now, we will simply attack as fast as the player can hit the mouse button. So that's the difference here. If you wanted to be able to hold the mouse button down to continuously fire a projectile, you would go with isActionPressed. But since we're looking for a distinct instance when the left mouse button has been pressed, we are going to use isActionJustPressed. So let's go ahead and save this, and let's go ahead and run our project. Okay, and our project failed to build because transform2D does not contain a definition for X. All right, so let's go back to our projectile, and right here where we see transform.x, as this is C#, it's important that all of our properties are uppercase, so go ahead and replace that lowercase x with an uppercase X, and go ahead and save this again. And let's go ahead and run our project again. It should build, and this time everything should be okay. Now, when we click our left mouse button, we're not going to see any projectiles yet, as we're not instantiating the projectile, but we should see our attack message printed out in our console below. So let's go ahead and hit left click, and let's see. Okay, and so as you notice, nothing is printing, and that's because we forgot one step, and that was to actually add our attack into our game loop. So that's going to be in our physics process. So right below look at, but before move and slide, we're going to go ahead and copy and paste our attack method. So now that that's in the game loop, when we run our project, we should see messages print when we left click. Okay, now if I hold the left click, only one message is printed. So that is our ideal behavior. Okay, now that our attack is working, we can go ahead and actually instantiate our projectile. However, before we do that, I just want to highlight another way that we can trigger our actions without actually going through the input map. So for now, we're going to comment out line 26. We're going to comment out attack. That way we know that's not triggering. Another thing we can do, we can actually check what inputs are happening and check if there is a mouse event happening and if that mouse is being pressed. So what we can do, now that we've commented out our attack, what we're going to do is going to create a new method here. And this is going to be a public override void underscore capital I input. And then we're going to pass in as a parameter input event at event. Okay. Now from here, what we want to do is we're going to check what that event is. So we're going to write an if statement. We're going to say if at event is input event mouse button. And then we actually name this as well event mouse button, because we're going to check if this is pressed. So in here, we're then going to have another nested if, and now what we're going to do is we're going to check if event mouse button is pressed. And if it is, as we were doing in our attack method, we're just going to print attack right now to verify that, yep, our left mouse button is being received. Okay, so let's go ahead and run our project again. And we should notice when we hit the left mouse button, that attack is still happening. Now, the interesting thing here is that we're just checking for the mouse being clicked, so your right mouse button still actually triggers that attack. So this is another potential implementation for this. It's another way that you can do this if you don't want to be working with the input map, for example. For the rest of this particular video, we're going to be following our attack method that we programmed initially. However, I wanted to point this out as well. Another thing that I want to highlight real quick before we move on is that this is another area where there is a good amount of deviation from GDScript and C# here. So this is going to be GDScript real quick. So this won't work here, but I just want to highlight what the difference would look like here. So again, we'd be overriding that input method. So we're still passing in our event. And from here, what we could actually do is we would check, again, if the event is an input mouse event, so input event mouse button, and then we would also check if that event is pressed. Right, and so then from here, for example, you would then call print attack or the rest of your attack logic. This should be how this would work in GDScript, and I just wanted to highlight that as, once again, that's another method you can do to get this to function if you don't want to use the input map. And I just wanted to write this out as well because the GDScript differs so significantly from the C# in this aspect. But okay, let's go ahead and remove that. And let's go ahead and uncomment our attack method. And let's save this again and run our project just to verify that this is all still working. So left click, and we're getting that attack. Right click, since we're using the input map, and nothing's happening. So only the left click is triggering our attack there. So great. Okay. Now let's go ahead and jump in to actually instantiating our projectile. So here at the top, we're now going to declare a packed scene, which is the name that is assigned, which is the variable name that Godot uses to reference other scenes. So this we're actually going to tag with export because we're going to want to be able to assign our packed scene to this. And we're going to say this is public, and it's going to be a constant, and this is going to be a packed scene, and we're going to call this projectile. Okay, now if we save this, right, in GDScript, this would then automatically appear as a field on our node in the inspector. However, because this is C#, we do need to build this before it will appear there. Oh, and let's see, what did we miss here? Oh, my bad. Okay, so we're going to get rid of the constant there. We're going to save this, and we're going to build. Okay, and now you'll notice right here at the top for player that we now have our projectile, and this is empty. So you can go ahead and click on this, and you notice it'll say new packed scene or load. Since we've specified that this is a packed scene, we're going to hit load. We're going to go to entities, we're going to go to projectiles, and we're going to click our projectile scene. Okay, now that our projectile scene has been selected, we can go ahead and expand our script again and go back to our attack method. So we're going to get rid of this print. And instead, what we're going to do is we're going to begin instantiating our new projectile. So we're going to say var new projectile is equal to projectile, this referencing the packed scene above, projectile dot instantiate, and then we're going to cast this as a node 2D. Sorry, there we are. So what we're going to do is we're going to call getTree, and then we're going to say dot current scene dot add child new projectile. So now we've added the new projectile as a child of our current scene, so it'll be a child of the root node in world. Okay, from there, what we're going to want to do is we're going to assign the position. So we're going to say new projectile.global position is equal to our player's current position, so global position. And then we're also going to assign the rotation, that way it's firing in the correct direction. So dot rotation is equal to rotation. Okay, so let's go ahead and save this. And let's go ahead and run our scene. And if we left click, we can see our projectile. And if we left click a lot, we can see it print. We can see a lot of projectiles firing. Now another thing you'll notice is there's a lot of messages being printed right now. And every once in a while, you'll see output overflow. So another thing that we can do for debugging is we're going to minimize this scene right here. And what you'll notice over here in the scene is there's local, and then there's remote. So let's go over to our world, which is running right now, and let's click remote. And you'll see we've got our root here, then there's world, and now you can see all of the nodes that are actively in the game. And what you'll notice is all of the projectiles are here. They're not going away because they haven't hit anything, and we're actually having performance issues due to each of those projectiles printing out their position. And they're not going to hit anything, so they're not going to go away anytime soon. So let's go ahead and stop this, and let's deal with that right now. So let's move over to our projectile, and what we're going to want to do here is add a timer node. So our goal for doing this is that if our projectile hits a target, we want the projectile to disappear. However, we also want our projectile to disappear after a certain amount of time, because if it's not hitting anything, we would like it to eventually delete and not just be something that's permanently within our game. So let's go ahead and create this timer node. So let's bring back our ready function. So that's going to be public override void underscore ready. And we're going to go ahead and connect a timer right now. So what we're going to do is we're going to declare a timer variable, so var timer, and it's going to be equal to get node timer, and we're going to pass in the path of our timer. Now, in this instance, the timer is our direct child node of projectile, so we can just say timer. In GDScript, the shorthand for this, which we don't have in C#, is just $, and then you type timer, and that would give you access to this node. But okay, so now that we have our timer, and it is of type timer, we can go ahead and connect a function that will trigger on the timer's timeout signal. So you'll notice we have our timer selected, and if we look over here in the inspector, we've got all these different properties of it. Right now it's got a wait time of a second. So what that means is our projectile is going to delete itself after 1 second. And that's a good amount of time for us. Depending on the size of your game and the speed of your projectiles, maybe half a second would do, maybe 10 seconds would do. So other things that we're going to do is we're going to turn on auto start because we would like the timer to start as soon as the projectile is created, and we're also going to turn on one shot. One shot means that as soon as the timer is done, it's not going to restart. It's just going to remain at 0 unless you were to restart it from programmatically. Now, that's something that's not important for us because as soon as this triggers, we're going to delete this projectile anyway, though I still like to have one shot turned on. So let's go ahead and now assign our function that will trigger on this signal. So timer.timeout, and then as it's done in C# plus equals on timer timeout. Now let's talk about what we've done here. So the timer here is this timer node. Timeout is, if we've selected our timer node, and then over by the inspector, let's click on the node tab, we should automatically be on signals. And what you'll see here are a bunch of different signals, some due to the object, some due to the node, and then one here due to the timer called timeout. Now this is lowercase because that is written in the GDScript formatting. Since we're doing C#, we capitalize the T for timeout. So then this on timer timeout is the name of the function that we are going to declare. So in our instance, it'll be private void on timer time out, and that'll be the name. If we wanted to call this, for instance, projectile delete or something like that, you could, and you just have to copy it and have it up there. And that would be how you would do that if you want a different name. We're going to go ahead and leave it as on timer timeout for clarity's sake. And we know that no parameters are needed because, as we can see in the function call here for the signal, that no parameters are passed in. You can see for these ones, for instance, child entered tree, that there are parameters. This takes a node, child exiting tree takes a node, but our timeout does not take any parameters. So we can go back to our inspector and we can expand our code space again. And again, to specify as well, in GDScript, this would be timer.timeout.connect, and then you would pass in the function, which, sticking with the GDScript code styling, would be on timer timeout with underscores between these and lowercase. So this would be how you would connect a function to a signal in GDScript. Godot's documentation does not offer an explanation for why the deviation between how signals are connected in GDScript and C#, other than one is done through the connect function and the other is done through the plus equals. So this is how we operate with this in C# for the time being. So in our on timer timeout function, we want to do two things. So first and foremost, we would like our object to free up memory and no longer be processing. So to do that, we call queueFree. However, just so that we can see this most easily, and this is not something I would leave in the game, I'm also going to call gdprint and just print out done, so we know that the timer is finished. What we've done here is we've connected our script for our projectile to the timer, and it's going to free itself when that signal occurs so that we don't encounter this memory overflow and those further problems of just constantly creating new objects that never delete. So if we go ahead and play our game again, we're actually going to run into errors because I forgot the semicolons again. And let's save that, and let's run our project again. Okay, so here we are. There we can fire a projectile, and you'll notice that the position prints until we see done, and then nothing else is printed again. So there we go, we see those dones appearing. So if we again go to our world and then look at our remote for what objects are here, you'll notice that there's just the world, the tile map, and the player. If we create another object, we'll see the projectile appear, and then it disappears. We can fire a bunch of these, we can see all of those appear, and then they disappear. Great. So that is how we can stay focused on memory management and just assure that we are not overflowing our game. So we can go back to our projectile, looking at our projectile script here, and we'll expand the code area again, and we can go ahead and get rid of those print statements, as there is no need for them in our game or for us to test at the moment. Furthermore, if we go back to our player, we can just make sure that there's no statements logging anything in here either, so this is looking good as well. Okay, let's go ahead and create our target. So I'm going to hit Control-N. Oh, and actually, I don't intend on creating a new script. I'm going to navigate to the scene, and I'm going to hit Control-N, and that automatically creates a new scene for us. I'll go ahead and minimize this main area so that we can start building out our scene here. So this is going to be our target. So as this is a target and not an enemy that's going to be following us around, I'm actually going to create this as a static body 2D. So this is like a character body 2D. However, this has no intention of being moved by the player or moved by external forces, as it says in its own description. So now that we've created our static body 2D, let's go ahead and, as we typically would do for an object like this, let's go ahead and create a sprite 2D. And then we're going to assign a collision shape 2D because we don't want our player to be able to drive through this. And let's assign a sprite so that we know what our collision shape should be. So let's go ahead and hit load. And again, if you're using your own assets, that's great. If you'd like to use the icon, the logo, the Godot logo again, that's also great. I'm going to go ahead and use those Kenney Tiny Battle assets. So I'm going to go into the tiles, and I'm going to select one of these gray ones here, and I'm actually going to click tile 0023. Let's open that up. Okay, let's go ahead and scroll down to this. Perfect. So let's take our collision shape 2D, and I'm going to go ahead and assign a rectangle to this. And I'm going to draw it to be roughly the size of our object here. Oh. Okay, great. And I'm actually going to move this up. There we are. Okay, now for this collision, we're going to leave this on layer and mask 1. That way our player can't drive through this object. So if we go ahead and save this scene, and actually before I do that, I'm going to rename the static body 2D, and we're going to rename it to basic target. Okay, and now we're going to save our scene, and it's already going to want to name the scene as basic target. So let's step up from projectile, and we're still going to save in our entities folder. So we're going to create a new folder, and this is going to be called basic underscore target. And then in here, and I'm going to call this in caps, basic target, and we'll hit save. So there's our basic target. So let's go over to our world and right click on the world node, and we're going to instantiate a child scene. That can also be done with Control-Shift-A, and we're going to click basic target. So let's zoom in here, and let's go ahead and drag its position. Okay, and I'm going to go ahead and create a few of these right now. So I'm going to click on basic target and then hit Control-D a few times, and I'm just going to drag these out from one another just to create sort of a wall of these objects. Okay, and let's go ahead and save this, and let's run our scene. Now currently, our projectiles don't interact with them in any capacity. However, if we were to drive forward, we couldn't drive past them. And that's because our collision objects that are on layer and mask 1 are hitting each other and not letting them pass through. So that's functioning as intended. But how do we get our projectiles to impact and change these objects? So let's go ahead and close this and go back to our basic target and start thinking about creating a hitbox in a composition-friendly manner. So clicking on our basic target, let's add a child node, and we're going to add an Area2D. From here, we're going to also go ahead and add a CollisionShape2D. Okay, let's go ahead and add a shape to that new CollisionShape2D. This time, we'll use a circle. And I'm just going to leave it for this default shape. So we can shrink this, and that's also fine. But again, it's generally preferable to favor the player and to make things more in their odds. So if your hitbox for an enemy or a target is a little larger than the target, that generally makes the game feel more fair to the player. Okay, so let's go ahead and click on our Area2D. And in the inspector, go to the collision, and we're going to take it off layer and mask 1, and instead we're going to click mask 2. This is our projectile mask, and we want this Area2D to be scanning for things on layer 2. Our projectile is on layer 2, so now we want to be looking at things on layer 2. Hence, we turn on mask 2. So let's go ahead and rename this Area2D to Hitbox. Okay, and now we're going to go ahead and attach a script to our hitbox here. So this is going to inherit from Area2D. I'm going to leave this as C#, inside our basic target folder is where we're going to save our Hitbox script. And that's okay for now, but as we build this out into composition, we're going to move that hitbox later to a place that's more applicable. So let's go ahead and create this. Okay, so we're not going to need this process, so we can go ahead and get rid of that right away. I'm going to expand this code area so that we can see all of this here. Let's go ahead and remove this comment as well. Okay, so in our ready, what we're going to want to do is attach a signal to onAreaEntered. So the reason we're doing that is we'll minimize this again. Having our hitbox selected, let's go ahead and click on the node tab and click on hitbox, and we'll see all these signals like we did for timer. However, you'll notice that Area2D has a lot more signals that can occur. What we're interested in is our AreaEntered signal right here. And as you notice, it takes a parameter of an area. And remember, our projectile is an area itself. Okay, so let's go back to our basic target. Let's click on our hitbox. Let's look at our node, and we can see that signal there. So going to our hitbox script, let's expand this, and we're going to connect those signals together with a function that we're going to define. So in this instance, we're going to call AreaEntered plus equals, because we're assigning a function to this signal, and we're going to type onAreaEntered. Now, because this script is on the Area2D, we don't need to get a reference to the Area2D because we are it, right? So looking at our projectile, the projectile is an Area2D. It has a child node of timer. So if we want to connect to the timeout signal, we need to get a reference to that timer before we can connect that signal. For our hitbox, we are the Area2D, so we don't need to get a reference to the Area2D to then attach to AreaEntered. That's why we can just call AreaEntered like this here on the ready. Okay, now we're going to call private void onAreaEntered, and we're going to pass in an Area2D as the signal required, as we saw over in the node tab. So area, there we are. Okay, so here, what we want to do is we're going to delete the object that's been hit. So the other thing, though, is that we're going to want to delete the projectile as well. We don't want one projectile to simply be able to travel across the map and delete any other area that it interacts with. So we want to make sure that the projectile is also removed from the scene. Now, fortunately, that's what this parameter is. This is the area right here that has hit our area or our hitbox. So if we want to get rid of the projectile, all we have to do is call area.queueFree. And that will remove the projectile. So the other thing, though, is that we want to remove our cells. Now, it might feel like we should call queueFree. However, you have to remember, we'll minimize this, that's on this hitbox here. So if we simply call queueFree here, what we'll do is we'll just delete the hitbox and its child nodes, but we won't do anything to its own parent node. So what we're going to need to do is we can't just call queueFree. We need to get a reference to the hitbox's parent. So what we can do is call var parent, and that's equal to get owner, and we're going to cast this, we're going to say it's a type node 2D. Then call parent.queueFree. Now, we could be very safe about this and say, for instance, if parent equals null, we could return. That way we're not trying to delete something that doesn't exist. However, alternatively, this isn't necessarily required because there shouldn't ever be an instance where the hitbox exists by itself, but that is exactly the type of case that could cause a problem for you later on if you're not checking for it. So let's go ahead and save this, And then let's go ahead and add our semicolons, since I keep forgetting to do so. And we can go ahead and run our project and see how this works out. Okay, so there are our objects. We can't travel through them, but if we fire a projectile, and if we fire a projectile somewhere else, it just travels and then eventually deletes itself. But if we fire at one of these objects here, there we go. The projectile and the target disappear. Perfect. And we're not getting any issues in our output. So another way to demonstrate the compositional aspect of this is let's turn our hitbox into a component that can be reused elsewhere. So let's go ahead and right-click on the hitbox node, and we're going to actually go down to Save Branch as Scene. Let's create a new folder called Components. And in here, we're going to create another new folder called Hitbox. Okay, and then right in here, we've got our hitbox scene. I'm going to go ahead and capitalize that, and we'll hit save. There we are. So let's save this, and let's go ahead and open our hitbox scene. Okay, here's the hitbox that as we remember it. And what we're going to want to do now is in our file system, go down to basic target, and right where that hitbox script is saved, let's go ahead and move this to its appropriate folder to be with hitbox over in components, just to keep everything together. Now everything should keep working, but let's go ahead and run our project again real quick and just confirm that all of this is still running and we're not getting any errors. Great. Okay, so let's demonstrate how this works as composition. And we're also going to show something that's a little bit of a sneaky problem that's associated with this. So let's go ahead and create a new scene. And this time, this is also going to be another static body 2D. And this one is going to be our advanced target. So let's go ahead and rename this to advanced target. Let's switch back to the 2D scene view. Let's add a sprite as we typically do. And let's add a collision shape. Okay. Once again, let's assign a sprite before we do the collision shape, just so we know what we're doing here. And again, you could use the icon. I'm going to go to the Kenney Tiny Battle assets. And we're going to choose something. Let's choose this right here. Okay, so tile 0013. Let's go ahead and open that up. And we'll zoom in. And something that I'm actually going to do is I'm going to take the transform of this sprite and I'm going to scale it up. I'm going to double it in all directions. Okay, let's go ahead and add our collision shape. We're going to use another rectangle. My mouse is super sensitive. Apologies. Okay, and let's go ahead and save this scene. We're going to go up one. We're going to create a new folder called Advanced Target. And save this as Advanced Target. There we are. Okay, so let's go back to our world. And let's go ahead and instantiate a child scene of our advanced target. Let's put it in place. Let's move it over here. There we are. Okay, so if we play the scene, we can drive around, and we can't drive through either of these objects. We can fire a projectile at these targets, but we haven't set a hitbox up on this one yet. So let's go ahead and close this and go over to our advanced target. And let's instantiate a child scene, and this is going to be the hitbox. And now you might see here that the hitbox has a collision shape, and it's this small circle. And we don't really have a good way to size this up. Now we could still, in a manner, scale it But as you can see, we're not scaling this as a circle anymore. We're scaling this as an object, and that's a bit awkward. It's not the best thing that could be done. So for the hitbox, what we actually want to do is we're going to go back to the hitbox scene. We're going to take the CollisionShape2D, and we're actually going to delete that node. So in this scene, right, the hitbox is an Area2D, and so it will give us this caution symbol saying, hey, I need a CollisionShape2D. However, we'll never have an instance of the hitbox without anything else associated with it. So if we go back to our basic target scene now, you'll notice that our hitbox no longer has a collision shape, and so it's giving us a warning. So let's go ahead and zoom in on our basic target, and we're going to go to our hitbox, and we're going to add a child node of a CollisionShape2D. From here, we're going to do what we did previously, which is we're going to create a circle shape, and we'll just leave it as the default here. And we'll hit save. Our hitbox is okay now. We're going to go over to our advanced target, and we're also going to add a child node of a CollisionShape2D. And for this, we'll again add a circle shape, except now we can properly scale the collision shape with this object. Okay, and let's save this. If we run our project, just due to our hitbox component there, we can already destroy those, and we can destroy our advanced target as well. So this is how you work with components in Godot. We could easily expand this to then work next to a health component as well, and that would be a way that we could continue to build out these other targets or enemies or even player NPCs and assign these various things like hitboxes and health components without having to do additional or specific code for each one of those particular things. We can just instantiate our hitbox or our health components to create that functionality really quickly. Okay, so that is how we create projectiles in Godot for a 2D game, whether that's a top-down game or a side-scroller, and how we can utilize composition to create an extensible hitbox detection system. Thank you so much for watching. For more videos, please follow Tundra Feed and Supply Company.